So, Deirdre constructs a polytunnel level part of her back garden. 5 vertical semicircular metal hoops, each of radius 2 meters, are attached to the brackets at ground level and is covered with a polythene sheet. The hoops are 2 meters apart. Find the area of ground covered by the tunnel. Please remember that the tunnel, in fact, covers a rectangle. So the rectangle which I just drew in blue is now represented in black in the space here. It's a gap of 2. 1, 2, 3, 4. 4 gaps worth 2 meters each. How much is that? 8. Radius is worth 2. That means there's 2 radiuses, which means it's worth 4. 8 times 4, 32 meters squared. Answer to the first part. Now, the hoops are also held in place by a straight metal piece attached at the top of each hoop. Find the total length of metal needed to construct the tunnel. How long is the metal part going down here? Can anybody tell me? 8 meters. 8 meters for the straight metal part. Now, we have a semicircle, and we need to find out the length of this semicircle. Okay? What is the length of a full circle? L equals, anybody? 2 pi r. If we cut that in half, what do we need to do? We need to half it. And what happens when we half 2 pi r? We get? Anybody? Pi r. Pi r. Okay? So pi r, lads, okay? Now, the radius is 2, which means each one of these is going to be worth 2 pi. Do you understand? 2 pi. How many hoops do we have? 1, 2, 3, 4, 5. It's going to be 5 times 2 pi, and that's going to be 8 plus 10 pi. And we're going to change it to decimals, why not? And what we get here is 39.42 or 416 maybe. 39.416 is a good answer. Any questions thus far? No? Okay, question 2. The polythene is buried in the ground to a depth of 25 centimeters. Okay, 25 centimeters all around. The dimensions of the area. Find the dimensions of the area of the smallest rectangular sheet of polythene that can be used. Okay. Okie dokes. This is a reasonably tough question, alright? Now, what I've drawn here is a full cylinder. Okay? So here is a full cylinder. Now, in the cylinder part of your tables, okay, you'll see a cylinder, like so. 2 ellipses, okay? And then you're going to see 2 vertical lines coming down. Now, do we have a full cylinder? Do we have a full cylinder? We have half a cylinder, because half of it is it's a semicircle. Okay, so the surface area, which represents everything that goes around the side of the cylinder, is what? A equals 2 pi r h. Do you understand? That's not including the top or the bottom. Not including it. Now that that's done, what's going to happen next is, guys, we're going to have to half that, aren't we? And what happens when you half it? What do we get? Pi r h when you half it. Okay, so we're going to get pi r h. Now that we've got pi r h, what is the radius of this? What is the radius? 2. Pi times 2, and what's h? Its length. What's its length? 8. That turns into 16 pi. Now what else did we forget about, guys? We also forgot about the part at the front, didn't we? Forgot about this as well. Yeah? So what happens here? What does it form when I shade in these 2 regions? Okay, from the picture, is the polythene at the front as well? Yeah. So we have to do the front and the back. So guys, what shape is the front and the back? They're both semicircles, and when you add two semicircles together, you're going to get a full circle. What's the area of a circle? Pi r squared. A is going to be pi times 2 squared, which is, what's that going to be? Pi times 2 squared? Sorry? 405, is that what you said?
4 pi.
4 pi. Oh, sorry, 4 pi. Okay, so we have. So we have 16 pi for the sides, and we have 4 pi for the front and back. Now there's a catch on this. What's the catch? Reread it again. The polythene is buried into the ground at a depth of 25 centimeters all around the tunnel, including both ends. Find the dimensions of the smallest rectangular sheet. Find the dimensions and area of the smallest rectangular sheet of polythene that can be used. Look at this, guys, okay? This part here represents what? Can anybody tell me? I'll make it a bit bigger. Okay? So let's do our maths on this. When you unravel a cylinder, it turns into what? A sheet of paper, doesn't it? Are you happy with that? When you unravel a full cylinder, a cylinder looks something like this. Okay? Sorry, 1 second. A cylinder looks something like this. Put this down here. 1 second. So do you understand what I'm doing here? And it obviously needs to be wider, doesn't it? It has to be wider than this, so this is going to be something like that. Okay? You happy with that? Now, that's one part of a cylinder, okay? And then we're going to copy, and then we're going to paste down here. Now, what's the problem with this? Do we have the full thing, or do we just have half of it? Do we have a semicircle or a full circle? We have a semicircle, okay? Now, we can draw the semicircle maybe 2 different ways, okay? We can, I'm trying to think now. Okay. So, what we can do here is we're going to draw 2 semicircles. Now, why isn't the semicircle the same length as the rectangle? What's going to happen? You're going to fold it upwards. Do you understand? And when you fold 2 sides upwards, they form the curved surface area. Are you happy with that? Okay? Now, what's the next catch onto that? What's the next catch? What has to happen to the sides? How much extra do I need off each side? Can anybody tell me? Okay. You need 0.25 extra on each side, don't you? Why do you need 0.25 extra? Can anybody tell me? It's buried into the ground. Okay, so that's our 0.25 extra. Okay. Now, it also mentioned that the front also has to be buried by 0.25, doesn't it? So, what's going to happen here then? We can actually just extend it out 0.25 and then put the semicircle on top of that, can't we? Okay? And likewise. Okay, guys? So, and like so, okay? Alright. Now that that's done, okay? What we're going to do next is, guys, we've got to figure out the size of each one. What length is it from here to here? What length is it from here all the way down to here? 8. 8. What length is it from here to here? Once again, remember. What? I'll tell you now. Just give me a second. We had a cylinder, didn't we? We did initially have a cylinder, correct? And to get around the cylinder, the length at the top is 2 pi r. Do you understand? All the way around is 2 pi r. But we're not using the full cylinder, we're using half a cylinder. So what's half a cylinder? What's half a circle? Pi r. So that's pi multiplied by r from here to here. Now what is pi multiplied by r? What is r? 2, isn't it? So this is going to be 2 pi. This part here is also going to be 2 pi. What length is it from here to here? From here to here. That's going to be 4. And this from here to here is going to be 2. So that's going to be 2. Oh, sorry. Not 4. Sorry. Sorry, guys. It's 4. The diameter is 4. And the height is 2. That is 4. And this part here is 2. Alright, guys. So there's your diagram, okay? Now what we got to do next is we got to find out what is the area of each one. Okay? So the area of... Can anybody tell me what is the area of the 2 semicircular sections? We did it earlier. What is the area of the 2 semicircular sections? Remember we got the area of the circle earlier. And the area of the circle is 4 pi. So this means that the semicircle is 2 pi. The other semicircle is 2 pi. What about the black rectangle in the middle? What do you think that is? What's the area of the black rectangle? We got it already. 16 pi. Because it's 2 pi multiplied by 8, which is 16 pi. Okay? Now we're on the green area. What do you think the area of the green area is? This green area here and this green area here. What is it, guys? 0.25 multiplied by 8. What's 0.25 multiplied by 8? 2. And what happens? We have 2 of them, don't we? So it's plus. The 2 green strips are worth 4. And now finally, what about these 2 blue strips? What are they? They're 4 multiplied by 0.25. And they're worth 1 each. The 2 blue strips are worth 1 each, which makes a total of 2. What's our grand total? 16 pi plus, anybody? 4 pi plus 4 plus 2. Add it all together, what do we get? 68.83 meters squared. Alright, guys. Now, I did make one assumption. I assumed that the polythene went down in the form of a rectangle underground. Is everybody happy with that? That's the assumption I made for the question. Okay? Okay, guys. Now that we've done this part and we've got the total area, we're now moving on. And what we're moving on to is part 2. Okay? Now, in part 2, what I asked us to do is the following. Okay? What part 2 wants us to do is this. It wants us to what it wants us to do is find the volume of the tunnel. And oddly enough, you don't need part 3 to do this. The volume of a cylinder is pi r squared h. Do you understand that? So a volume of half a cylinder is going to be what? Half pi r squared h. Is that alright? Okay. Now, what's going to happen next is this, guys. A half pi r squared h is going to be a half multiplied by pi multiplied by 2 squared multiplied by 8. What's that in the calculator? I think it's 16 pi, is it? Anybody tell? Okay, let's go with 16 pi. So 16 pi, what's the units? Anybody? meters cubed. Volume, meters cubed. Now, to finish, Deirdre constructs a rectangular raised bed of height 25 centimeters inside the tunnel. There is a space of 20 centimeters between the bed and each side of the tunnel. Now guys, currently speaking, the tunnel is how large? The tunnel is, it's a semicircle, isn't it? Okay. The tunnel is currently 4 meters wide and 8 meters long. Okay. What do we have to take away from each side? What is 20 centimeters in meters? It's worth 0.2. Take away 2.2s from 4 and what do we get? 2.2s away from 4 and what do we get? Anybody? 4 minus 0.2 minus 0.2? Okay, it's 3.6, okay? And what's 8 minus a 0.2 minus another 0.2? What is it? 7.6, okay? So it's going to be, oh, that's not 8, that's 7.6, okay? So, the garden is going to be 3.6 meters wide, 7.6 meters long, and how many meters high? Where does it say that? Raised bed of 25 centimeters. It's going to be raised up 25 centimeters, which is 0.25. How do you find the volume of soil that you can put in there? Can anybody tell me? Anybody know how to find the volume of soil in this box?
The length times width times height.
Length times width times height. And what is the length times the width times the height, Brian?
3.6 times 7.
And in the calculator?
6.84. Oh no.
6.02 maybe?
That's 0.22.
Oh, 2.25 you say? Sorry. Thank you. 6.84, exactly what Brian said, okay? 6.84 meters cubed. Now next thing guys. Soil costs €80 per tonne. €80 per tonne. Okay? 1 meter cubed of soil weighs 0.75 tons. Does my bed weigh more or less than 0.75? 1 meter cubed weighs 0.75. So what do I need to do? Multiply 6.84 by points. And what do we get? .84 multiplied by 0.75. What do we get? 5.13. 5.13 meters cubed. Oh, sorry, not meters cubed. 5.13 tons. Yeah? Now, how much does each ton cost again? So multiply that by 80. What do we get? 410.40. Everybody happy with that? Okay.